In this video, I'm going to show you what is a sequence and how we can find a formula for the nth term or general term of a given sequence. Consider this list of numbers: 2, 5, 8, 11, 14, 3n-1, and so on. This list of numbers is an example of a sequence. Sequence is a list of numbers in a definite order. 2 is the first element of this sequence, and we show the first element with a sub 1. 5 is the second element of this sequence. 8 is the third term of this sequence. 11 is the fourth term or fourth element of this sequence. 14 is the fifth term of this sequence. And 3n-1 is the nth term or general term of this sequence. Nth term or general term of a sequence is a formula that we can use it to find any term of that sequence. So with having this formula, we can find all the terms of this sequence. For example, for finding the first term of this sequence, we have to plug in 1 for n in this formula. So the first term is 3 times 1 minus 1. 3 times 1 is 3, 3 minus 1 is 2. So the first term of this sequence is 2, which it is. Second term of this sequence is 3 times 2 minus 1. 3 times 2 is 6, 6 minus 1 is 5. And if, for example, we want to find the 10th term of this sequence, we have to plug in 10 for n. 3 times 10 is 30, minus 1 is 29. So the 10th term of this sequence is 29. We denote sequences in any of the following forms: a sub 1, a sub 2, a sub 3, a sub n, and so on, while listing the terms. Sometimes we just write the formula of the nth term in the curly bracket like this, or in this form. The nth term in the curly bracket, and also we mentioned that n starts from 1 and it goes up to infinity. We can use any of these forms to show sequences. Now let me show you some more examples of sequences. n over n plus 1, n from 1 to infinity. This expression inside of the curly brackets is the general term of this sequence. So a sub n is n over n plus 1. And we know that with having the general term or n term, we can find all the terms of a sequence. For example, the first element of this sequence, a sub 1, is 1 over 1 plus 1, which is 1 over 2. The second term of this sequence is 2 over 2 plus 1, which is 2 over 3. The third element of this sequence is 3 over 3 plus 1, 3 over 4. So if we want to list the term of this sequence, the first term is 1/2, second term is 2/3, third term is 3 over 4, and the nth term is n over n plus 1. Another example: -1 to the power of n over n n from 1 to infinity. The general term of this sequence is negative 1 to the power of n over n. First element of this sequence is negative 1 to the power of 1 over 1, which is negative 1. The second element of this sequence is negative 1 to the power of 2 over 2, which is 1 over 2. The third element of this sequence is negative 1 to the power of 3 over 3, which is negative 1 over 3. If we list this term of this sequence, we have negative 1, 1/2, negative 1/3, and in general the nth term is negative 1 to the n over n, and so on. Another example, a square root of n minus 1. In this example, general term is a square root of n minus 1, and so the first element is a square root of 1 minus 1, which is 0. The second element of this sequence is a square root of 2 minus 1, which is 1. The third element is a square root of 3 minus 1, which is a square root of 2. The fourth element is a square root of 4 minus 1, which is radical 3. So if we list the elements of this sequence, we have 0 as the first element, 1 second element, a square root of 2, a square root of 3, and general term is a square root of n minus 1, and so on. Now look at this example, 10 to the power of n over n factorial. So the general term of this sequence is 10 to the power of n over n factorial. Hopefully you are familiar with n factorial, but just in case, I remind you what is the factorial of a number. 0 factorial is defined to be 1. Also 1 factorial is 1. 2 factorial is 2 times 1, which is 2. 3 factorial is 3 times 2 times 1, which is 6. 4 factorial is 4 times 3 times 2 times 1, which is 24, and so on. Let's back to our example. The first element of this sequence is 10 to the power of 1 over 1 factorial. 10 to the 1 is 10, 1 factorial is 1, so the first element is 10. The second element of this sequence is 10 to the power of 2 over 2 factorial. 10 to the 2 is 100, 2 factorial is 2, 100 over 2 is 50. The third element of this sequence is 10 to the power of 3 over 3 factorial. 10 to the 3 is 1000. 3 factorial is 6. If you simplify this fraction, you can write it as 500 over 3. So the list of the elements of this sequence is 10, the first element, 50, second element, 500 over 3, which approximately is 166.6, and so on. The nth term is 10 to the n over n factorial. Now we want to learn how we can find general formula for the nth term or general term of a given sequence. For example, consider this sequence: 2, 4, 8, 16, 32, and so on. This is a list of numbers, but the problem is that we are not given the general term or the nth term of this sequence. We want to know what is the formula that generates these numbers. We want to find what is the formula for a sub n. By looking at these numbers, you can see that 2 is actually 2 to the power of 1, 4 is 2 to the power of 2, 8 is 2 to the 3, 16 is 2 to the 4, 32 is 2 to the 5th, and so on. As you can see, the first element of this sequence is 2 to the 1. Second element, a sub 2, is 2 to the 2. A 3 is 2 to the 3. Fourth element is 2 to the 4. Fifth element is 2 to the 5. So by looking at this pattern, we can guess that probably a sub n, the general term or nth term of this sequence, should be 2 to the power of n. Now look at this example. 1, 4, 9, 16, 25, 36, and so on. And we want to find a general formula for a sub n. We want to find the nth term of this sequence. We can consider 1 as 1 to the power of 2, 4 is 2 to the 2, 9 is 3 to the 2, 16 is 4 to the 2, 25 is 5 to the 2, and 36 is 6 to the 2. Now probably you can guess a formula for the nth term of this sequence. Note that the first term is 1 to the 2, second term is 2 to the 2, third term is 3 to the 2. So nth term is n to the power of 2. Now look at this example. 1, 4, 7, 10, 13, and so on. And again we want to find the nth term of this sequence. If you notice to this sequence, we can find each term with adding 3 to the previous term. If you add 3 to 4, it equals 7. If you add 3 to 7, it equals 10. And if you add 3 to the 10, it equals 13, and so on. If you remember from high school, this type of sequence is called arithmetic sequence. And if you remember, the general term or nth term of such a sequence is a sub 1, which is the first term, plus n minus 1 times d, which d is the difference between consecutive terms. So in this particular case, a sub n, the general term or the nth term, would be a sub 1, which is the first term. The first term of this sequence is 1. So 1 plus n minus 1 times d. The difference between the terms is 3. Now if we simplify this relation, we have 1 plus, if you multiply 3 in the bracket, we get 3n minus 3, which if we simplify it, finally we get to the 3n minus 2. So this is the formula for the nth term of this sequence. To make sure that this formula is correct, let's check it. For example, if we plug in 1 for n, we get 3 times 1 minus 2, which equals 1. And the first element of this sequence is also 1. If we plug in 2 for n, we get 3 times 2 minus 2. 3 times 2 is 6, minus 2 equals 4. So second element of this sequence is 4, which it is. The third element of this sequence is 3 times 3 minus 2. 3 times 3 is 9, minus 2 is 7. The third element is 7. So you can use this formula for arithmetic sequences. Sequences that the difference between each term and the previous term is constant. Only in that case you can use this formula for finding the nth term of that sequence. Now look at this example. 12, 7, 2, negative 3, negative 8, and so on. Try to find the nth term of this sequence. If you notice to the terms of this sequence, you can see that if you subtract 5 from each term, you can find the next term of this sequence. 12 minus 5 is 7. 7 minus 5 is 2. 2 minus 5 is negative 3. Negative 3 minus 5 is negative 8. And so on. So the common difference between each term and the previous term is negative 5. This is another example of an arithmetic sequence. And so we can use again this formula to find the general term of this sequence. A sub n equals to a sub 1, which means the first term, which in this case is 12 plus n minus 1 times d, which is the common difference. And in this example, the common difference is negative 5. Now let's simplify this formula. A sub n equals to 12 minus 5n plus 5. 12 plus 5 is 17, and so we can write the nth term as 17 minus 5n. So this is the formula for the nth term of this sequence. If you want to make sure that this formula is correct, you can test it. For example, let's find the fourth term of this sequence with the formula. We have to plug in 4 for n. If we plug in 4, we get 17 minus 5 times 4. 5 times 4 is 20. 17 minus 20 is negative 3. And if you look at the sequence, you can see that the fourth term of this sequence is also negative 3. Now look at this example. 1 over 2, 3 over 4, 5 over 6, 7 over 8, 9 over 10, and so on. The numbers in the numerator of these fractions are odd numbers, and the numbers in the denominator of these fractions are the even numbers. And if you pay attention, each number differs by the previous number by 2. 1 plus 2 is 3. 3 plus 2 is 5. 5 plus 2 is 7. 7 plus 2 is 9. And the same situation is in the denominator. 2 plus 2 is 4. 4 plus 2 is 6. 6 plus 2 is 8. 8 plus 2 is 10. So the numbers in the numerator are an arithmetic sequence, and also the numbers in the denominator are an arithmetic sequence. So we can use this formula separately for the numerator and the denominator. The general term of this sequence can be written in this form: a sub 1, which is the first term of the numerator. The first number in the numerator is 1 plus n minus 1 times d. The common difference is 2. And for the bottom also we can use this formula. Again, a sub 1 is 2 plus n minus 1 times the common difference, and the common difference in the bottom is also 2. Now if we simplify this formula, we have 1 plus 2n minus 2 over 2 plus 2n minus 2. And finally we can write the numerator as 2n minus 1 all over 2n. And so this is the formula for the nth term of this sequence. For example, to check that this formula is correct, let's find the fourth term of this sequence. If we plug in 4, we get 2 times 4 minus 1 all over 2 times 4. 2 times 4 is 8, 8 minus 1 is 7, 2 times 4 is 8. Which we can see that the fourth term of this sequence is also 7 over 8.